Ready?
Yep.
Perfect. So our project is for CS410 Text Information Systems is on parental oversight for Spotify. Our team members are Sam Parmar, that's me, Vijay Mishra, who's joining me here, and Pragya Mishra. Pragya is in India, so she's unable to join us for this presentation. Next slide, please. Here is our outline for our presentation. So some background, Spotify, it's an audio streaming platform originally out of Sweden. As it's gained more and more popularity, we see more children using the platform. Currently, Spotify doesn't have a parental control feature for family accounts. This feature is being developed. So the intent behind this project is that by allowing parents to track listening history and explore trends over time, they might be alerted to sudden changes in listening choices that might be indicative of a mood change that the child is experiencing. So this mood change might be due to external circumstances such as bullying or association with bad company. So that leads us to the next slide on the function of our tool. So this project, it provides a tool for parental oversight on Spotify. Parents with access to this tool and their kids' Spotify accounts would be able to analyze trends in listening history and detect sudden changes. Next slide. So the general flow diagram here, it shows that Spotify user logs in, the user provides permission for our app. The Spotify API pulls Spotify listening history. The Genius API then uses that song data list to provide to us the lyrics data, and the lyrics data is then passed through our sentiment analysis model, and the emotions for each song are output. The song emotion history is then plotted in an interface and provided to the user. Next slide. So my colleague here, Vijay, will pick up.
Thanks, Sam. So this slide shows our the architecture of our solution and the technology that we have used. As you can see here, we have used Angular for front end. We have used Node.js for implementing a login server for Spotify OAuth, and we also used PySpark for our machine learning requirements. We implemented 3 servers, 3 processes that run on Amazon cloud. We got a T2 large Ubuntu box on Amazon so that we can actually run it in the public cloud and make it available to anyone who wants to try it out. The flow works like this. The user accesses our application and the request goes to the Angular page, and it directs. The first thing that we want to do is to authenticate the user against the Spotify because we really want to get the data from the Spotify. So once the user goes in, the request is handed over to the login server, which eventually directs the user to the Spotify server to authenticate and give consent to the user to the application, to Spotify, to allow our app to access their private information on Spotify, like listening history and stuff like that. So once that is done, a token is generated here by Spotify, and it's given to our app, which is to our front-end app, and we make a REST API call to the app server implemented in Python. With that information, our process goes and gets the data from Spotify. Basically, it's getting the last 50 songs that the user has been listening. Once we get the song data, we go to Genius API, Genius system, to get the lyrics for those songs. Once we get the lyrics for each of the song, we run them against our trained model here, which gives us back the sentiment for each lyric. We will go over in the next slide how we generated this trained model as well. So when the sentiment is returned, it's returned back to the user and it's displayed on the screen, and they can see the trend that about the listening history. This diagram shows the core of what we did. Basically, the sentiment analysis. One of the biggest challenges that we faced to do this one is to get the annotated sentiment data. We found a lot of data available on positive and negative sentiments, but there are very few available on the emotional analysis like happy, sad, anger, etc. After a lot of searching, we finally found a data set from world.data, which was emotional analysis on the tweets. And we actually used that, and it gave us decent results. So what we did is we took the data from their data set, and we could use only a subset of it because they had almost like around 50,000 tweets. We could not use all of them because my machine was running out of memory. So I sliced the data into a smaller set and used that to train our model. Basically, I just used 4 emotions out of few, like 6 or 7 emotions that they had. So once we have the data, we ran the data against our Python, against the code that we have written in Python, implementing all these steps. So it goes through tokenizer first, then it goes through stop word remover, and then the hashing terms where each string is converted into numbers, identifying each text string. Once we have this data, then we split the data into 2 parts. 70% of the data is used for training, and 30% is used for testing that trained model that we have created. That's what you see here. So we first train the model, and then we use that model to test against the 30% of data which we have, to see how accurately we are able to identify the sentiment for that 30% of the data. And then we check the accuracy of our model, how good or bad it is. After quite a few iterations that we ran, and like tweaking the parameters, we were able to get accuracy of 58.8% for this data set. And we used that. We kept that model for our training. And we saved the whole pipeline of the model that we need. We created a pipeline that we'll need to run the prediction. We saved it on the file system, and we actually checked it into the GitHub as well. But the file which is used to create the model is also there in the GitHub repository. Okay, so it's a quick demo time. So let's go to if we go to site. So it takes you to this page to authenticate with Spotify, and if you do that, okay. Since I've already given the consent to this application, it actually did not stop at asking the consent. But when you do it, you will actually be stopped, and you will find a page, something like this. Like this, where it will ask you to give a consent, and you have to click on agree. And once you do that, this is like a one-time thing. Once you do that, next time onwards, you will directly land on our application page, which is this. So here you can see that we have plotted. So we get like only 50 days of data, and as already mentioned, that Spotify does not allow us to get more than that historical data. So we can only plot the last 50 songs, and right now what we have is it gives us like around 4 days of songs, and you can see here, like for each day we can see like how many sad songs we had, how many angry songs we had, how many neutral and how many happy songs we had each day. If you kind of go over this graph, uh, some of uh, some of the songs we could not find the data for them in Genius, and so they actually identify as neutral because we don't have anything to go by. And that's why you see sometimes a very high number of neutral songs. Maybe we should filter them out, as this is one of the next iteration thing. So this kind of gives you a trend of, like, if someone has been listening to a lot of happy song and suddenly they start listening to a lot of sad songs, if something is going on, this really helps us understand that. Specifically, like if we start storing this data in data set and then plot over a big period of time, then it will really highlight the change that is going on with someone's kid or even someone themselves, but more likely that the use that we see here is for the kids, especially with a lot of stress that is going on with the kids nowadays in high school and all. We also are showing here the raw data, so you can actually see like whether it's how good or bad it is. So you can see here you have a song name and you also have the lyrics here and how we have classified it. So you can probably see whether this, if you know the song, you know the lyrics, you can tell whether this is correctly identifying the sentiment of the song or not. And that's pretty much what we have in demo. Feel free to go to this URL. We are going to keep this is on Amazon box, where we actually have to get a T2 large, which is not free. So we will be running it for another week or so. So please feel free on checking this out and let us know how you find it. With that, let's go to the last part of our presentation. Sam, over to you.
Okay, so just some points on future direction in case people want to extend the project forward. So Spotify, as we mentioned, it only allows the last 50 songs to be retrieved. 50 songs to be retrieved. So persistence in the application, ideally some database would be great to really carry this project forward and better historical analysis. The model can also be improved by training against all the data, so that's another opportunity. Next, the sentiment anger, it's very limited expressed in the data that we use. So maybe more representation of this emotion might also boost the accuracy, not accuracy, but at least maybe accuracy and representation of the model. And then lastly, more views can be generated by providing varying insights into the listening history. So we have some other additional programs we created which we weren't able to implement in our interface. They might also utility to the parent, and also incorporating some of these features in the model might also improve the solution. So that brings us to the end of our presentation. Thank you.
Thank you.